checking 1, 2, 3. Is everybody okay? Should be. So about 5-second delay. Yeah, let me send out an email to let everybody know that we move to this stream instead. We will start in a few minutes. Sorry about that. Oh, sorry, I sent the wrong link. Right. That's right. Right. By the way, there's a live chat. If you have any question, they just type to the chat. Uh, and so, is the audio and video okay? Right. Sorry about the delay. I try to I try to put this link uh, put on the same link as I sent yesterday. For some reason it doesn't work, so I have to make the whole new link. So it should be fine. Uh, so as mentioned yesterday, all we need is just paper and pencil. So I'm going to write everything here. The note, it's going to be, we'll go over the note will be over there, the calculator, and then I will update the section here. Anyway, so let's start. Right. So the first day I should go over what we have in calculus 1. So namely two main things, derivative and integrals. So of course the note will be on that side. Right. If you write this, you can write on the separate sheet of paper. So we'll refer back to it later. Yeah. Right. As mentioned before, if you write a note, there's some example in some pocket of note that at the end of the semester I ask you to send it back to me. So make sure you all organize everything clearly. So first let's write on the rule. Power rule. Derivative of x to the n is n times x to the n minus 1 power. And derivative of any constant is 0. Okay. And then I just keep the exponential rule here. Derivative of e to the x is the same thing as e to the x. And if we have another base, it will be ln of the base and the same thing. Right. Now let's go to trigonometric rule. Function. Right. derivative of sine is cosine. And derivative of cosine is negative sine. Tangent secant square cotangent negative cosecant square secant secant x tangent x and cosecant negative cosecant cotangent. Right. Derivative of ln of x is 1 over x. Uh, Derivative of log base a of x is 1 over x, but we have to type to write the ln of a. And then of course product rule and quotient rule. Right. So that all the derivative rule. Like I said, just put that on the side, and that's all the derivative rules we have. Now we go to the examples. By the way, if you have any question, please type it on the chat. And actually, I'm signed on to the my Gmail account, which is mn214math. I'll type that on the chat. Uh, I don't know why it does that. By the way, I'm not checking the school email right now, so I'm just on my personal email here. Right. Right. So this is two example. I'll find the derivative right. So this is just basic. So the x to the fourth, we can use the power rule, square root of x also power rule, but we have to rewrite that term. X squared at the bottom also we have to rewrite. So I haven't done anything yet. I just rewrite the problem. And square root of x, we should write as x to the 1/2. And the x squared at the bottom, that x to the -2. Right, that minus. So we have to rewrite everything as a power of x. And after that, we can find the derivative. So the derivative is take the power down and original power -1. So 4 times -3, that's -12 x cubed. And then we take that 1/2 original power -1. 1 minus 1/2 is minus 1/2. And then take out the -2 original power -1. -1 minus 2 minus 1 is -3. Right. So we will have pretty much that. -12x cubed plus 1/2. If we want to the x to the 1/2, -1/2, move to the bottom, become positive 1/2, and minus -2 is plus 2, x to -3. Sorry, I should have my phone on. Oh, can do the same thing for -3 and move that to the bottom. Right. And finally, x to 1/2. Let's just write square root of x and then 2 over x cubed. Right. So we don't have to write like this. The derivative could be any of this, but I said we can hold the way to that. Right. Next. Yeah, I think it is fine. The only thing that I miss is I cannot really ask you any question here because yeah, I could put that in the conference like Zoom. But if I use any software like Zoom or Skype, I cannot put everything like the calculator and then two cameras at the same time. So I have to stick with YouTube. Besides, the YouTube later it will be that the replay option, which is natural. Anyway, so for this one, we can take the derivative of 3x. We can take the derivative of sine x, but this is going to be a product. So we're going to use the product rule. Where u is 3x and v is sine x. Right? So derivative of 3x is 3, and derivative of v, derivative of sine x is cosine x. Right. So we'll take derivative that is a product. So I will write the product rule here. So u prime 3 and v sine x plus u 3x v prime cosine x. Right. Of course, that nothing we can really do here. Just 3 sine x and 3x cosine x. Right. So we just that. Next, derivative of cotangent. 7x to the second minus 4. By the way, like I said, if there's any problem with the stream, or if you have any question, please type on the chat. I'm actually reading the chat and make sure everything is fine. So we certainly can take derivative of cotangent. Derivative of cotangent is negative cosecant square. So that's easy. But this inside the cotangent is not just x, it is a polynomial. So what we have to do is just put the parentheses around that. So when we take derivative, I just use black ink here. So when we take derivative of cotangent, it will be, doesn't matter what it is inside. Derivative of cotangent is negative cosecant square, and the rule, one rule that we did not write here, which is the most important, the chain rule. The chain rule say always multiply by derivative of the inner function. So in that case, that is 7x squared minus 4. So it doesn't matter what inside the parentheses, that's what we have. So we have 7x squared minus 4 and 7x squared minus 4 inside the parentheses. Right. Negative cosecant square of 7x squared minus 4, there's nothing here, which is good. Just need to take derivative of this. And derivative of that is 14x. Right. And that's it. Except the 14x here by itself, we can always move in front. So in that case, we don't have to write the parentheses around it. Then we have cosecant square. Right? Yeah. So that is the chain rule. And we have a lot of chain rule here. Just a question. Do you see the note on that side clear enough? Try to zoom in a little. Might be. Okay. That be better, because that's just a problem. We don't need to see the blank space in between. Right. Next one. So we have sine x and then plus 4. So the plus 4 is not in the sine x. Yeah. But like I said, I'm drawing everything again on the paper, so that should be fine. the note here is fine, right? The note on the paper. I think I check it should be fine. Right now, so we have pretty much two problems. The a sine x and plus 4 sine x plus 4 is on the exponent, so we might want to put the bracket here for the exponent, and then the tangent x. So that's pretty much one term, and then derivative of the tangent x. So that is the second term. Right. So now we take derivative. And whenever possible, we use derivative with the prime sign. We don't write dz over dx unless we have to, or otherwise I prefer just use the prime notation. Right. So derivative of e exponential function, derivative of e to the x is going to be the same thing. And chain rule says we take derivative of that. Doesn't matter what is inside the exponent. That's what we have. And then derivative of tangent is secant square. Right, so that takes care of the tangent. Right. So take derivative of the exponent first, and then derivative of the tangent is secant square. Right. Now on inside the exponent is sine x, and then plus 4. Right. This is a little small here. Right. Then we just take derivative of sine x plus 4. Derivative of sine x is cosine. Derivative of 4, that constant will be 0, and minus secant square. Right? So we have just that. And then the cosine of x, if we write in front, we don't have to write the parentheses. So unless this raised to some power, if this is just the first power, or there's no power, I usually write in front of that, so we don't need the parentheses. If that's a little confused, just put a dot here. So cosine of x times e to the sine x plus 4 and minus secant square. Yeah, that's even better. Right. Next. For x cubed minus 2. Right. So once again, chain rule. Put the parentheses around this. And then what is derivative of ln of x? Derivative of ln of x is 1 over x, the reciprocal function. So we'll have derivative is 1 over, parentheses, and then chain rule say multiply by derivative of it. Doesn't matter what inside of, doesn't matter what is the argument of the log. It's always 1 over the argument and then derivative of it. Anyway, for x cubed minus 2, and then for x cubed minus 2. Right? So we have 1 over 4x cubed minus 2, and derivative of 4x cubed is going to be 12x squared. Again, this does not raise to any power, so we try to move that somewhere so we don't have to put the parentheses around it. So multiply 1 on the top, we have 12x squared, 4x cubed minus 2, and that's what we have. We cannot cancel the x and the x here because of the minus 2. If everything is the product, everything are factors, we can simplify. But with the minus 2, cannot do anything. Right, so it's like that. For example, if you take the note like this at the end of the semester, I will ask you, for example, send out the note for example 2E, something like that. Then you just take the picture and send it back to me. That part of the grade. Next. Right. So, uh, so we have the cosine 2x minus 3 and then cube. First of all, the cube here, uh, we have to take the cosine first and then cube. So I will have to rewrite this as cosine of 2x minus 3 and then the cube is outside. So that's the first thing we have to do is rewrite that uh, so we know how the function are composed. Alright, then we'll take derivative. So inside is something raised to the third power. Derivative of a third power is 3 times, just keep it, of the bracket square, right? The power goes down and the original power minus 1. And chain rule say multiply by derivative of what's inside. By the way, whenever you put whatever you put on the live the chat, I will not display that to the later on. I will disable the live chat on the replay, so it will not display the live chat. No, anyway, so inside the bracket we have cosine of 2x minus 3, cosine of 2x minus 3. Okay, so we have 3 cosine of 2x minus 3 squared. Right, that one doesn't have any derivative, so that's where we start for that term. Now we take derivative of cosine 2x minus 3. Right, switch different colors here. So we have a parentheses around the cosine, the angle or the argument of cosine, and derivative of cosine is negative sign of the parentheses, and then derivative of the parentheses. Doesn't matter what inside the parentheses. Right. So cosine of 2x minus 3 squared, we can put the 2 in here. That's just cosmetic. There's no actually, there's no rules or anything. Just usually we put the square here. It will look better. And derivative of 2x minus 3, derivative of 2x is 2, 3 is a constant, derivative is 0. Right. Now, again, the sign and the 2, they do not have any power here. So I put the negative and the 2 and the 3. All of that multiply together, right? So we just take the negative 2 and 3, so make it negative 6. Right? And then we have cosine square 2x minus 3, and then sine 2x minus 3. Right. On the first day, we don't really need to use the template. Wait. Okay. We will. Yeah, if it is too fast or too slow, or just let me know. I can speed up or slow down a bit. Oh, gee. Oh, sorry. What's that? Y. Right. So, square root. You cannot really take the derivative with the square root. We have the power rule though. So, it will be better if we just have everything in power. Right. So, we write the problem like that. It'll be easier to take the derivative. Right. Derivative of something to the 1/2 power, it's going to be take out the 1/2 original power minus 1, and then the chain rule. So I have 1/2 original power 1/2 minus 1. To check to make sure the calculator works. So 1/2 minus 1, and convert to fraction. Yeah, just to make sure the calculator works. So 1/2 minus 1 is minus 1/2. And then chain rule says time derivative of what inside the parentheses or the bracket. So we have secant x minus 5, secant x minus 5, right? That's derivative here. So we have 1/2 secant x minus 5 minus 1/2, and derivative of secant x minus 5, derivative of secant is secant tangent, right? And it's just multiply to it, right? And we can put that in front. Right here, and then we have the secant x minus 5 to negative 1/2. next we have a note. We use the chain rule a lot, and so later on, when we see something, then we just always like this is when we have sign of kx, for example, and when we take the derivative of that, then that's going to be cosine of something, and then we just take cosine of kx times k. So because we're going to see this a lot, especially in chapter 8. So if we have sine of something times x, in that case constant, when we have a constant multiplied to x, when we take the derivative, just take the derivative of that, then multiply by k. So if we have cosine of kx, don't even need to put the parentheses around it, is negative sine of kx and multiply by k. So if we multiply k into x, the derivative will multiply k on the outside. But inside, we still have kx as the argument. Same thing for tangent. Which is secant square and then multiply by k on the outside. So it will be same thing for secant, tangent, cotangent, secant, and cosecant. Probably I don't need to write everything. If it's secant, it is secant x. So secant kx, tangent kx, and then we'll multiply by k. Notice that whatever we do inside the parentheses or the argument is kx, we never mess up with the kx. If it is kx, it will stay kx. And you see all of this from the 2x minus 3, we will still have 2x minus 3. We cannot change any of that. Same thing for exponential. Exponential is going to stay the same, except multiply by k to it. So as you see, for a constant k multiplied by x, the derivative will be just the same, but we multiply by k. Pretty much because k is the derivative of kx. So we see this a lot. So like the derivative of e to the 2x is 2 times e to the 2x. Right, finally the log. Sorry. Log. I mean kx. I just use pencil, but pencil is not very easy to see for the camera. Kx. Right. Derivative of ln of kx is going to be 1 over kx, and then we multiply by k, of course. So we have k over kx, and the k and the k cancel, which is 1 over x. So all of this, we just multiply by the k in front of it. We take the derivative, multiply by k to it. If there's a constant, multiply to it. If it is x squared, yeah, we have to take the derivative of that. So it's not going to be just k. So we use this a lot, especially in chapter 8. So if there's a constant k, multiply by k, and then we take the derivative, the argument will stay the same. Alright, so that's the first part of the section. Now we go to the second part. integral. By the way, the first page that I write on the derivative rules, I'm going to write that on this page, on the derivative rule that I write earlier. Now I'm going to write the integral rule below it. So we have one page for reference. By the way, I will post the formula, set everything on one page, so you can bring out later, or you just copy like this. Right. Right. Power rule. Integral of, I use u to the n, u is u to the n plus 1 over n plus 1. And since we divide by n plus 1, it cannot be 0, so n not equal to negative 1. Right. Integral of u to negative 1, the reciprocal function, or derivative of 1 over u, is ln of absolute values of u plus c. Right, so that is the power rule. And then exponential rule, or exponents. Integral of e to the, I should use u, is the same thing. And integral of something else, by something else I mean the base is not e, it's going to be a to the u, and then divide by ln of a. Right. Next will be a bunch of trigonometric function. So integral of cosine is sine. Integral of sine is negative cosine. Right. Pretty much I just write this in backward. Integral of cosine is sine. Integral of negative sine is cosine, but I move the negative to the other side, and then pretty much just that. Secant square yes, the video, it will be, there will be a replay. It will stay there. I'm going to make the playlist on YouTube for this course. So if you have stepped away for a few minutes, it is perfectly fine. I just type it. but we do have a break in between. I'm not going to go 3 hours straight. Second U, tangent U, that is second. Sorry, I tried to put everything on one page, so it's kind of small. Cosecant, cotangent is negative. That's something. Right, and there will be some others trigonometric function. Integral of tangent is ln of secant integral of cotangent is ln of sine. There's no negative here. Integral of secant is ln secant plus tangent. Plus c. Sorry. Yeah, still okay. And then cosecant is ln. Actually, it could be negative ln of cosecant plus cotangent, but we write a conjugate. And then the fundamental theorem of calculus, that's too important, and we need to know that, so I'm not even going to write that out. Right, so what we have here is just the basic derivative and integral. I'm going to, like I said, I'm going to post the some formulas on separate page, so we can easily refer to. Right, so we have that. So actually, let's just take 5 minute break here. I will answer any question if you have, but other than that, we continue in 5 minutes. Right. And one thing that is very important to a class is somehow I have to take attendance, and we cannot really take attendance like this. So what I do instead is I will create a discussion board on the campus, just so we can introduce ourselves. I will send an email about that. So when we have the discussion board, you're just going to post something. So just make sure that you are in the class, and because I have to certify that somehow to participate in the class. Right. Like I said, we'll continue in 5 minutes. That will be 4. Continue in 4 minutes. I prefer to, because when I sent out a survey earlier, turns out that not everybody has all the resource at home. Even if you have the printer at home, you still probably don't want to print out 130 pages of the note. So in that case, I write everything on paper. Note that at the end of the semester, I'm going to ask you to take the picture of some of the note that you take. That for part of the grade. And once again, I apologize for the delay at the beginning of the class. I tried to put the stream on the same link that I sent earlier. I couldn't do that. So I have to be on the new link. Right. This is what I try to make when I try to design a course. So pretty much I count every Monday, Wednesday, and Friday. So the homework I do not put it here because the homework when I post on my math lab it will stay there and then you only need to finish all the homework at the end of the semester. So this is the plan. Except that I didn't put the review for calculus here. So we spend the first 4 days including the review. By the way, since we have the lecture here, whenever you take the test, whatever the test is going to be online. We will not spend any Monday, Wednesday, and Friday particular on the test. So we have. Yes, I only post the homework up to this section. I did not post the rest because this course is completely new. So I have to design everything from scratch. So I don't have everything. I don't even have the review there yet. Right. So actually, we will not. Once again, we will not spend any day here to take the test. You can take the test any time you want. The test is due at the end of the semester. It is on my math lab, by the way. You see it. I will explain it when I make the first test, which I didn't. So the plan is to go like 2 sections a day. That will be. I'm not sure how many. Yes, but on a bigger scheme, I finished all the note. The only thing that I finished is the note. So we have 130 pages, and we're going to do that on 20 days. So that pretty much if we can get like 10 days, I mean 10 pages a day, it should be fine. And the page, let's see, we're on page 3 here. Now, like I said, all the Mondays, Wednesday, and Friday from 8 to 11, that will be the I will spend all of those time for YouTube streaming. The test, you have to take it at your own time. Right. Do you have any other question? Right. So I taught some online classes before, but it's now never like this. Usually, if it's online class, then the lecturer, we don't have time for lecture. This is face to face originally, so we have to do the live stream, and this is, I think, is the only way to work. I could use Zoom or Collaborate or Skype or other things, but the YouTube I'm more familiar with, except for the live stream. I haven't done the live stream more than a year. But anyway, so for the next time, I will not send you the link for the stream unless I see the stream works. So for Wednesday, I will go online, make sure the stream work, and then I will send you the link. I think that will be better. I don't want just send a link that doesn't work. Right, now integrate. So all of this, I'll just make sure that we need to write is the power of x because we have the power rule. The cube root, that is 1/3 power, and x at the bottom. Yeah, we can write x to -1 if we want to, but that doesn't do much here in this case. Right. So we just rewrite it. We haven't done any integral. Now the integral part, the x squared integral of that is x cubed over 3. So the power is increased by 1. That 1/3 increased by 1. So that is 4/3. And divide by the same thing. The x, if we increase by 1, will be x to the 0 power. But then we cannot divide by 0. So x to -1, that completely different rule. That is ln of absolute value of x. There's a 5 in front of it. Right. Indefinite integral, there will be a constant c here. Right. So that's just power rule. And then 4 divided by 3, or if we want to, whatever we divide by is multiply the reciprocal. We multiply by the reciprocal, so 3 over 4. And that is 4 over 3. Plus c. So that's what we have. Right. Right. So we integrate. Integral of sine x is negative cosine x. And there's a 3 in front of it. Integral of cosine x is sine x. and integral e to the x is e to the x. So that's it. Yeah, except we put the minus in front. It will look better that way. Except I forgot the constant c. Right? Right. Note. Right. What I want to write the note here is similar to what I tried to write the note for this one for the derivative. So what happens if we multiply a constant k into x? On the derivative, it's multiply the k in front throughout of the problem. So derivative, we multiply by k. Now for integral, what happened? Of constant k. So for example, uh, what happened when we have something like this? So remember derivative, if it is derivative, we multiply by k. This is the integral, so we will divide by k. And the argument is kx. We will never mess up with the argument. Right? Just 1 over k. And integral of sine is negative cosine. The angle is kx, so it will be kx. There will be a negative in front. E to the kx is the same thing. But we have to divide by k, or multiply by 1 over k. So, derivatives, for derivative, we multiply by k. Yeah, derivative, multiply by k, and integral, we divide by k. So that is just x and then kx. Of course, that is the substitution rule. Let's just do one more. Like secant square kx. Secant square is tangent, so it will be a tangent. The argument will stay the same, but we have to divide by k. So that's what we do with the integral. Always divide by constant k when it is multiplied by x. And the argument, the angles, will always stay the same, kx, throughout the problem. Right. Now we continue with the example. Right. One important thing on the derivative and the integral rules that I write out earlier on the derivative and integral rule. The chain rules, and the substitution rule, the chain rule for derivative, and the substitution rule for the integral. I will not write that out because that is the most important. So here what we have is a substitution rule. So if you're taking my calculus 1 class, then there is a certain style that I go by here. So we use substitution, and I will let u equal to, usually will be inside the parentheses. I will let u equal to x to the 4th plus 3. So we have u. What we need to do next is solve for dx. So if u is 2x to the 4 plus 3, we check derivative. And this time I write derivative using du over dx because we need to have dx. That's why we write it like this. Derivative of that is ax cubed. And we can move the dx over. And then if we want to solve for the dx, we divide by the ax cubed. Right, so we have two components, the u and then the dx. Every substitution problem, we need to have those two. Right. Now we can substitute back into our problem. X cubed, haven't done anything with it, we stay x cubed. Square root 2x to the 4 plus 3, that is u, and then dx is du over ax cubed. And if everything works out perfectly, there will be no more x. And if there's a constant, just take it outside. But it will stay at the bottom. The 8 stay at the bottom. But we have to put the 1 on top. That's all. Right, to integrate this square root of u, we can write u to the 1/2 instead, because we can use the power rule when we have the power, obviously. Right, so at 1/8. Now apply the power rule for this. Increase the power by 1, so u to the 1/2 plus 1 will be 3/2. And then at the bottom will be the same as the power. 1/2 plus 1 will be 3/2. It's multiplied here. Let's see. Right. Multiplying fraction is, we actually, the 3/2 is at the bottom. So 3/2 at the bottom, so we divide by 3/2. So that 3/2 here at the bottom, divide by 3/2 is multiply reciprocal. Right? And then 2 and 8 cancel out. 1 on top, 1 on the bottom. Top is just 1, and that is 4. Sorry, the pencil is not very easy to see. So we have 1 on top, 4 times 3 at the bottom, so that is 12. And then u to the 3/2 plus c. So we have 1 over 12. U is 2x to the 4th plus 3 to the 3/2 plus c. So that is the standard substitution problem. We need two components, u and then dx. And there will be more substitution problem. Usually on the first day of class, I will not take the whole 3 hours, but there are too many uncertainty in the class, so I'm sorry I have to use all the time I have, because who knows what will happen. So we have to use all the time we have here. Besides, we should start it last week, so we lost a week. So we, at the same time, all the tests are online now, so we don't have to spend class time for the test. So actually, we should be okay. Right. So same thing. On this one, we have to use substitution because we cannot integrate like this. Unless, of course, if we're talking about this problem, then we can perfectly split. So that's different. We can split the top, cannot split the bottom. So that's different. And there's no quotient rule here. So the only thing we can use is substitution. So we'll let u equal to the denominator. And then we'll take the derivative, and we're going to solve for the x. So the derivative is negative 2x. Multiply the dx over, and when we solve for dx, we have du over negative 2x dx. So two components of the integral, the u and the dx. When we have those two, we can substitute into the original problem. Right. So we have 4x on top, and the bottom, that will be u. Dx is du divided by negative 2x. Right. Works out perfectly here. The x's cancel out. The negative 2 is a constant. Can take it outside. It will stay at the bottom though. The 4 on the top is constant. You can take it outside. So we take the constant outside, and what we have is the 4 on the top, negative 2 at the bottom, and then the integral. Let's see what we have. X cancel out, 4, negative 2 come out. Just have 1 over u du. Of course, we can write u to negative 1, but that is like the lateral move. So 4 over negative 2 is negative 2, and then 1 over u integral is, I just want to copy that for now. 1 over u is ln of absolute value of u plus c, and we replace into u. That's what we do here for that one. The blue pen kind of low on ink. You will see a lot of substitution on the integral. Just like we see a lot of chain rules in derivatives. Right. So x times sine, so that doesn't work because we know we can only take the integral of sine of something. So if we have u here, that should be good. So and then we'll take the derivative of it. Derivative of 5x squared minus 2 is going to be 10x. Move the dx over, and then divide by 10x. And there are two components of a substitution, u and dx. So we have x, and then sine 5x squared minus 2, so that is u, and then the dx, we can say du over 10x. X is cancelled out, the 10 is constant, take it out sine, but will stay at the bottom. And inside the integral, we only have sine u du. Right. Integral of sine is negative cosine, right? And then the negative times 110, so that's negative 110. Cosine of u plus c, and negative 1 over 10 cosine, and u is going to be that. And then plus c. Right. That's just a standard substitution problem. Right. Now we have some definite integral. The integral with the limits. Integrate from 0 to 3. Square root of x plus 1 dx. Right. Pretty much the same thing. Square root of x, we can do it, but it is square root of x plus 1. Cannot really do it, but we can use substitution. So if we let u equal to x plus 1, pretty standard, take derivative. Derivative of x plus 1 is just 1. Multiply dx to this sign. That's good. We have dx, which is equal to du. So that's easy. The only problem here is this one has the limit. Originally for x equal to 0 to x equal to 3. So in this case, we change the limit to in terms of u. When x equal to 0, we're going to put 0 in for x. And when x equal to 3, so it will go from, instead of from 0 to 3 for x, it will go from 1 to 4 for u. So now the limits, instead of 0 to 3, it will be from 1 to 4. Still the square root. X plus 1 actually is just u. And dx, this one easy, equal to du. And in particular, u equal to 1 to u equal to 4. So since we already changed from x to u, at the end we do not need to go back into x. On this problem, we have u, but we have to write in terms of x. We don't need to do that here, because the limit here are for u already. We will write that as the 1/2 power, so it is easier to integrate. So integral of u to the 1/2 is u to the 1/2 plus 1. 1/2 plus 1 is 3/2. Divide by the same thing. Going from 1 to 4. Divide by 3/2 at the bottom is multiplied reciprocal. So I'm going to flip. That is 2/3. Right. So fundamental theorem calculus, put in the upper limits, then put in the lower limits, and subtract those two. So I'm going to put 4 in 3/2. And then subtract. Put 1. There. Right. And test the calculator again. 4 to the 3/2 is 8. That's nice. And 1 raised to any power is 1. So we subtract this. A of this minus 1 of that, it's going to be 7, right? So just factor out, if you will. 7. 7 times 2, so that would be 14 over 3. Right. This is a definite integral. We certainly can check it. Hit math, and then go down to option 0. Sorry, option 9. So math, and then number 9. Pull from 0 to 3. Square root of x plus 1. By the way, oh, sorry. By the way, I sent you the link to install the calculator on computer, right? It should look something like this. The reason I did not use the TI-84 color edition because this one it look a little bit the front look a little bit bigger, so it's easier to see on the screen. But it should be the same, right? Okay, we change that to fraction. Yeah, 14/3. So we're good here. The next one might take some space, so we'll go to next page. Right. Yes, the blue one run out of ink. Right. So we have e to the x, which is good. E to the 3x also good. The problem is the plus 4, right? So that's only that. So we use substitution again for 3x plus 4. So we have u, and now we need to solve for dx. So we check derivative, right? Move the dx over du equal to 3 dx, or dx equal to du divided by 3. Sorry. Yeah, I spell this so I make sure that there's no leaking in the ink. Anyway. Right. So we just do the substitution. U and then dx. Now we convert the limits as well. Originally x equal to -1 to x equal to 2. When x equal to -1, u equal to 3 times -1 plus 4. So that is 1. X equal to 2, same thing. So that is 10. So we have everything for the substitution. Original x go from -1 to 2. Now u go from 1 to 10. E and 2x plus 4. So that is u. And dx du over 3. Right. And the limit here is for u. There's no x here to cancel, which is good. There's a constant 3 here. Put on the outside. 1 to 10. Oops. Get the 3 on the outside, put at the bottom. Just a to the u du. Integral of a to the u, a to the u, just the same thing. This one has the limit, so fundamental theorem calculus, you go from 1 to 10. Right? So be 1 over 3. And a to the u, we'll put 10 in it for u. And then put 1 in for u. And subtract them. A to the 10. A to the first, it itself, just a. If we want to, we can factor out 1/3. A to the 10 minus a. Right. The answer is not anything nice and even because a to the 10 is what we call the transcendental. This is meaning it's not even certainly irrational number. Right. Make sure it works. Let's check. Math number 9. Going from -1 to 2. Second ln, that a to the 3x plus 4. Right. That's certainly not what we have here. Of course, the calculate this DI84 cannot give us this answer. But we have to check that indirectly. Let's say 1/3. By the way, if we want fraction alpha y equal to, that is fraction of 1 over 3. And then a to the 10 minus a. The a by itself is here. Or we say a to the 1 power. Doesn't matter. But even though the calculator did not give us this answer, at least there's on the calculator we see numerically the same values. Two more. Right. Now we'll try to do this. First of all, most of the problem up to this point we use substitution. If we let u equal to cosine of x, it doesn't work. So just want to write this quickly. If we let u equal to 1 over x, we have 1 over u, where u is equal to cosine of x minus 1. We take du equal to sine x. So if we substitute in or du, just do that quickly. So this is du over sine x. So if we use substitution, we end up with this. The sine x here cannot simplify. So substitution will not work. I have to try something else though. Right now we don't have any rule. Actually, this kind of classic problem. So there's a classic solution. First of all, let me write. Substitution doesn't work. Because the x will be there. The x left in the problem. It will not work. What we do is that is we multiply by the conjugate. Multiply top and bottom by cosine of x plus 1, which is the conjugate of this. Right. So how did that help? So on the top we just have cosine of x plus 1. At the bottom, cosine times cosine is cosine squared. Cosine times 1 minus cosine and minus 1. The reason when we multiply the conjugate, the middle terms cancel out. And we have cosine squared minus 1 dx. Right. And you say, why? How did that help us to do the problem? Right. What we can see here is the cosine squared minus 1. We can use Pythagorean identity. So we have cosine squared plus sine squared equal to 1. So if we want cosine squared minus 1, so why don't we minus 1 on both sides? And we're going to minus sine squared on both sides. So we do that, subtract 1 on this side, subtract sine on both sides. So when we do that, we have cosine squared minus 1 equal to negative sine x. I mean sine squared of x. Right, and we certainly can substitute back in here. So continue our problem. Cosine of x plus 1 over negative sine squared. Right. Now, remember, we can split the top, cannot split the bottom. So certainly we will split it here. Cosine of x over sine squared. Actually, it's negative. Right. So sometimes I just have to check to make sure that the quality, the sound is good. Right. Cosine over negative sine squared. Right. It's going to be negative. The sine square at the bottom, I write sine times sine. On the top, I just have a cosine. And there's nothing left, so I have to write 1. Again, that's going to be negative. And 1 over sine square, that is cosecant, right? And square. Right. Cosine over sine is cotangent. 1 over sine cosecant. Cotangent cosecant, the integral is negative cosecant. and cosecant square is negative cosecant square is derivative of cotangent. Or we just have negative cotangent of x plus c. So that will be cosecant x minus plus cotangent x plus c. Right? Right. Kind of. Yeah, this one might take some space also. Right. So this one, not substitution. Yeah. Because substitution doesn't work. Because when we have u, we need to solve for dx, and the dx have to somehow cancel with the x. If we have 2x cosine of x minus 1 is u, there will be something left. The x will be left, and substitution will not work. We'll try substitution again on this one. Let u equal to x minus 1. Right? If u is equal to x minus 1, we take the derivative. Be just 1. Move the dx over. So this one easy. Du is equal to dx. Right, that's good. We have u and we have dx. And du is dx. So dx is du. Sorry. It should be u. Right. Right. So most of the substitution problem, we should cancel all the x. Like this one, the x is cancelled out and the number is constant. We can take it outside. On here, the 3, we certainly can take it outside. The 3 is constant. So we can take the 3 outside. It's a constant. But other than that, we're left with the x here, which cannot be cancelled. So that is a problem. So if we have an x left, then the substitution usually will not work. Luckily on this one, it's very simple. We have u equal to x minus 1. So different color here. This will be orange. U is equal to x minus 1. So from here, if we add 1 plus 1 on both sides, u plus 1 is equal to x. So sometimes we have to solve for x as well, if there's something left, and something very easy to solve for. So we will substitute to this x. instead of x, that's going to be u plus 1. We have u plus 1 on the top, and the bottom, since we're going to use the power rule, let's rewrite that as the 1 half. Right. Then we can split the top, but not the bottom. Right. Now, u over u to the 1 half, by default, this to the first power, this is to the first power, and when we divide them, we subtract the exponent. 1 minus 1 half is 1 half. U to the 1 half at the bottom, move to the top, then 1 half. And then we use the power rule. This will be easy. U to the 3 half over 3 half, and then this is negative 1 half plus 1, u to the 1 half over 1 half. Let's see. Right. Multiply reciprocal, divide by 3 half at the bottom, turn to 2/3. And 1 half at the bottom, flip, that is the 2 over 1, which is 2. Right. And then just multiply the 3 inside. 3 times 2/3 is going to be 2. U to the 3 half, and then 3 times 2 is going to be 6. And finally, u is x minus 1. Right. So, yes, sometimes substitution will require more than just u and dx. If there's an x left in the integral, uh, we may have to solve for x as well. But this is rare. Right. So that is the review of the calculus that we have. Next, we go to section 7.5. This actually is the last section on count 1. So it's just a review here. Right. Let's take 5-minute break, and then I'll come. We'll continue in 5 minutes. Oh, the 6u is the 3 distributed to the 2. So 3 times 2, that's going to be 6. And then the 3 times 1 half is 2. usually during the break I'll check email. So if you have any question, you can always send an email. I check it during the break. Right. Next we go to section 7.5. This should be the last section in the calculus 1. So this is just a quick review. By the way, I encourage you to be organized so it's easy. We know if we have to go back to the note later, we know what write out the section and everything clear. So this section 7.5 inverse trigonometric function. Right. Let me update the title here too. As well, I don't need to type the whole thing. Oops. Right, good. So whenever we go back to the note and we know watch the video again, we know what we're talking about. Right. So number 1, inverse trigonometric function. In the note on that side, let me zoom in. So obviously when we have y equal to, now let's focus on the sign. When we mean y equal to sine inverse of x, that means x is equal to sine of y. So we should switch in x and y, we go from the function to the inverse. So that's easy. The most important is what's going to be the domain and range. So let's do the graph. So I'm not going to go over all the definition here, but I'm just going to say it. Let's do the graph. The sine x, sine of 0 equal to 0. So suddenly we have this point. So that is the sine function. It could be better. Anyway, so we have here negative pi over 2 and pi over 2 where it reached the maximum of 1, minimum negative 1. Right. So that is the sine function. Right. So what we're trying to do is to find the inverse. the sine function. Only one-to-one function has inverse. So we have to choose the function, that part of the function that is one-to-one. So we always choose this part which is in the first quadrant. And then we have to choose something to cover the whole range from -1 to 1. If we're going to choose this part, this is not one-to-one function, and only one-to-one function has inverse, so that part does not work. What we have to choose is this portion here. So from -pi/2 to 0 and then pi/2. Now on the unit circle, 0 to pi/2, that is the first quadrant, and -pi/2 to 0, that is the fourth quadrant. So this part of the function is one-to-one, and y values from -1 to 1, and x values from -pi/2 to pi/2. So when we write y equal to sine inverse of x, that x values have to be the y values here, have to be between -1 and 1, and then the y have to be between -pi/2 to pi/2. So that inverse sine. We can do the same thing, but now we're just going to fill out the summary of this table here. Right. Right. I really need the ruler here. Right. Just make a table like the one in the notes. That's good enough. Right. So it has 6 rows for 6 functions and 3 columns, the function, domain, and range. So we have sine inverse cosine inverse, tangent inverse, cotangent inverse, secant inverse and cosecant inverse. Right. Of course, we did this. If you took out one, you should have this already. Now, just want to summarize. Right. The domain, the sine, cosine, the function bound between -1 and 1. So for that one, for this, the first two, the domain is the whole, I'm sorry, from -1 to 1. So the domain for this one is -1 to 1. For sine, cosine. For tangent and cotangent, it's going to be the whole line. Because the tangent function quickly is like that. So to go to infinity as well. So domain and domain for the sine, cosine, inverse between -1 and 1, tangent and cotangent, the whole thing. Cosecant and secant inverse. It is on the outside. So we will write -infinity to -1 and 1 to infinity. Right. Now on to the range. The range sine inverse, we did say earlier, is quadrant 1 and quadrant 4. So Q1 and Q4. In particular, near pi over 2 to pi over 2. Right. I try to use different color here. Right. For cosine, we can do similar to this part. Cosine is different, but it's going to be quadrant 1 and quadrant 2. Meaning that go from 0 to pi. Right. Tangent inverse and cotangent inverse. Tangent inverse is going to be similar to sine, and cotangent inverse is similar to cosine. So Q1 and Q4. Right. So it is like this, except there will be no midpoint. Meaning that we go from negative pi with, wait a minute, sorry, no endpoint. Because in the domain it's not closed on the end, so it's the same thing for the range. It's be parentheses So there's no endpoint. Sorry, because we can always check with the notes. So no endpoints. Sorry, because so is the domain. Right. For cotangent will be same thing as cosine, quadrant 1 and quadrant 2, and also no endpoint. So instead of this, it go from 0 to pi and do not including the endpoint. Sorry, I have the question. So this is quadrant 4, right? So 1, 2, 3, 4. So this is 4. Yeah, some books when they said secant and cosecant, they can use quadrant 1 and 3, but we use that. Anyway, and secant is reciprocal cosine, so just write because of this. So this will be similar to cosine, except where cosine equal to 0. Yeah, so that is the fourth. So. Right. So secant inverse kind of like cosine, and cosine is quadrant 1 and 2, so it's still quadrant 1 and quadrant 2, except on this one there's no endpoint, as no midpoint, no midpoint. So we have just like this. We go from 0 to pi over 2 and excluding the pi over 2. So just like this, except no point in the middle. And cosecant will be same as sine. Quadrant 1 and 4, except there's no midpoint. So we go from negative pi over 2, including, and then 0 to pi over 2. Close. Right. So just the domain and range, the summary. So that's nice and all, but most importantly, um, it will not be as important as what we did, which is derivative and integral. Right. So most importantly, can we take derivative and integral? Mostly derivative that involving this. Right. Before we do that, we need to practice some simple trigonometry. if theta is that, so originally we will start with sine inverse of 2/5 equal to theta. That's what we start with, original given. That's what we have. Now we're going to have the cos, take the sine on both sides. So we apply sine on both sides. Just have the sine on both sides. Right. The sine of the sine inverse, they will cancel out if it is defined. So just cancel out. So we have sine of theta is equal to 2/5. Right? Now, we're going to draw a triangle. The angle is theta. Right. Sine is opposite over hypotenuse. So the opposite is 2 and the hypotenuse is 5. In that case, the equation given by Pythagorean theorem, square root of 5 squared minus 2 squared, which is 25 minus 4 squared, 21. So the equation is square root of 21. And then we just go back to cosine theta. Cosine is adjacent over hypotenuse. Adjacent is square root of 21 and hypotenuse is 5. So that's all we do. This is a very simple but very important technique. We need to know this in order to find the derivative, and later on in section 8.4 we'll certainly see this also. Right. So I have cotangent inverse of cosine, cotangent of cosine inverse of x over 4. What's that equal to? Right. So what we know is that the cosine inverse will give us an angle. So we let that be theta. So let theta equal to cosine inverse of x over 4. Right. Next, we're going to apply the cosine on both sides. Cosine and cosine inverse cancel out. We have cosine of theta equal to x over 4. Right. So this is good. And for a triangle, the angle is theta. Right. Cosine, the ratio for cosine is adjacent over hypotenuse. So adjacent is x, hypotenuse is 4. opposite, what is that? So it's going to be square root of 4 square minus x squared. Actually, it could be negative too, because when we take the square root, let me do this again. So the opposite square plus the adjacent square equal to the hypotenuse square, right? Pythagorean theorem. So we solve for opposite. Subtract the x squared, we have 4 square minus x squared. But when we take the square root on both sides, they are plus or minus. And you say why we didn't have the plus or minus here from the beginning. Actually, we should do that too. We could too. But then again, I'll go back to this problem real quick. Like I said, it should be plus or minus. But remember, the sine inverse, whenever we do the sine inverse, I go back to the previous one. For the sine inverse, it will come out to quadrant 1 and quadrant 4. So the theta here is in quadrant 1 or quadrant 4. Right? And cosine of anything in quadrant 1 and quadrant 4 is going to be positive. So usually, technically, we should have the plus or minus, but in most of the problem, there would not be a problem. That would not be the case. So like, for example, cosine inverse will give us quadrant 1 and 2. Right? And cotangent of quadrant 1 and 2 actually could be negative. So just put the plus or minus here. It doesn't matter. Right? But on the test, if you happen to forgot the plus or minus or don't have the plus or minus, I will count that as correct, because technically we don't have to worry about that. When we go to section 8.4, yeah, sometimes we have to. But we assume that everything works out perfectly. Right. I will go back to the problem. Theta is the cosine inverse. So we just have cotangent. Cotangent is adjacent over opposite. So adjacent x over opposite. Right, now let's check. Again, cosine inverse is going to give us in quadrant 1 and quadrant 2. Cotangent of quadrant 1 and 2 could be negative, so we don't know the positive or negative. And besides, the inside of this have to be positive as well. You cannot have negative inside square root. So there are a lot of factors into this. Right. Now, if we want to do this perfectly, if x is positive, it will end up with positive. If x is negative, it will end up with negative. So actually, in this case, the plus or minus here is not really relevant. We don't need the plus or minus here. So like I said, most of the problem, we don't have the plus or minus in the square root, because the plus or minus will take care by itself. The reason is the cosine inverse is negative only when x is negative. If x is negative, then we don't really have an extra negative here. Right, so that's one. It's good. Right. And And then we have the table for derivative of the inverse trig function. So that's nice and all. Remember, we have to satisfy the domain of the problem for x. But I said, don't need to memorize that, because that's not easy to memorize. I'm not asking to do that. This is what we're going to do. Right. We don't even need those rules to find the derivative. We just do that with just some basic derivative rules. Right. So the first thing we do is similar to what we have earlier. We have the sine inverse to try to get rid of that. So I'm going to just take sine on both sides. Right. The sine and the sine inverse cancel out. We have sine y, sine of y equal to x squared plus 4. So that's pretty simple there, right? Now, what we're going to do next is using implicit differentiation. Meaning that we're going to take derivative, assuming or assume y is a function of x. Right. So derivative, we take derivative both sides. Derivative of x squared plus 4, that is just 2x. And derivative of sine y is cosine of y. Because this is implicit differentiation. Y is a function of x. So we have to have y prime here. Right. Now we just want to solve for y prime. Is 2x over cosine of y. Right. We just need to solve for cosine of y, and that will be good. Right. Now, what we have is sine y equal to x squared plus 4 we certainly can draw a triangle for that. Right triangle. Y is going to be the angle, and sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Opposite hypotenuse. Right. So the angle is y. Opposite is x squared plus 4. Hypotenuse is 1. And the adjacent will be y squared minus x squared plus 4 squared. Again, you don't need to put the plus or minus there. We assume that everything is in everything is defined. And then finally, we substitute back into the problem. Actually, just do this. Cosine of y is adjacent over hypotenuse. Adjacent is that divided by 1. Divided by 1 is just itself. So cosine of y is just square root of 1 minus x squared plus 4 squared. And so we substitute back into cosine of y. That's what we have. Right. Next we have this one. I can keep that as a reference. Right. So the first thing we do is get rid of the cotangent inverse. So we take cotangent on both sides. That we do. Right. So that will be cotangent of y is equal to cotangent cancel cotangent inverse 3x minus 5. Right. That will be the same thing. Implicit differentiation. Implicit. Where we assume that y is a function of x. And then we take derivative both sides. Derivative of 3x minus 5, that's just 3. Derivative of cotangent is negative cosecant squared. Implicit differentiation says multiplied by y prime. Right. And then just divide by negative cosecant squared. So we have y prime equal to 3 over negative cosecant squared. Right. Let's rewrite this as negative 3. And then cosecant squared, just write that as cosecant squared. Right. Just need to find cosecant y, and that should be it. Right. So that is from a triangle. So we have this cotangent. I write that as a fraction. Cotangent is adjacent over opposite. So we have a triangle. Adjacent and the hypotenuse is given by the Pythagorean theorem, 1 square plus 3x minus 1, 3x minus 5 square. And finally, we need cosecant. Cosecant is reciprocal of sine, so hypotenuse sine is opposite. So hypotenuse over opposite. So that is the cosecant. Substitute back into the cosecant. Will be that square root. The square cancel the square root. So that's what we have. So that is page 2. I think we're going to stop here, and besides we run out of time. So it will be the format of the class will be similar to this, except I won't be able to send you the link before class tomorrow on Wednesday. So on Wednesday, just about 8 o'clock, just check your email. You should have the link. I make sure I will send out the link of the live stream, so we don't have to have the problem like the beginning of the class. So I apologize for that once again. On Wednesday, when I send a link, that link should work, but it is a few minutes before class. And finally, I hope everybody is doing okay during this time. I try my best to make it work, and try to give you as close to a lecture class as possible. So including this, I cannot take attendance. So I'm going to post the discussion board on eCampus. When I do that, I will send you the instruction. Just make sure you go there, introduce yourself, and just make sure that I know that you are actually in the class, so I can make sure for some other reason I certify that you are in the class. But other than that, we stop here, and then we pick it up on Wednesday from here, from integration. I hope everybody do okay. Have a nice day. See you on Wednesday.